Okay, so back to what's left of this link layer today. So far, we have mostly looked at shared technology for sharing. So we looked at Ethernet and hubs and switches. How do you interconnect things? There's always multiple points trying to talk to multiple other endpoints on shared links of one sort or the other. Of course, there's also a lot of times you just have to go from one point to another, and then you have separate protocols because you don't want to be doing all the work that you do, for example, in Ethernet to manage sharing. So one of the simplest of these protocols is PPP. But before that, let's just look at what else is out there. So the basic idea here is that there's one sender, one receiver. Okay, so it's pretty straightforward. So what that means is the obvious things. You don't need MAC anymore. You don't need to manage traffic. There is only one person sending. There's no need for an address anymore. And so if there's only two people in a town and one road connecting them, you don't need any addresses. You want to send data out. Out means it can go to only one other place. And commonly, you see these in from home and a dial-up link. It's a point-to-point link or an ISDN line. Some of the popular protocols are PPP. That's the one that we'll look at today. And HDLC, it stands for High-Level Data Link Control. Both are point-to-point protocols, essentially. So let's just get to PPP. So now there's no sharing. There's only two endpoints. Still, there's certain things that you have to do. You need to frame the packet. You need to still have lower level information to get the packet across. You need to be able to carry packets with any network layer. Generally, you use IP, but you have to be prepared to carry if there's another network layer on top of you. And then at the endpoint, you hand over the packet to whichever network layer is specified. So we'll talk about this in a little bit. Transparency, sort of like an obvious thing to do. Obviously, you should be able to carry any data. So we'll see its significance in a minute. PPP has some error detection, basic, same kind as before. It has to be able to do basic housekeeping to detect when the link is ready on the other side and signal link failure to the network layer and so on. And even though there's no link layer addressing needed, the two network layers have to be able to communicate with each other. Okay, so there's some negotiation involved in making sure that the data goes correctly between the network layer endpoints. So this is all very basic, nothing special. So just to emphasize what's in and what's out of PPP, it does not have any error correction. There's no flow control. Out of order delivery is okay in the sense that PPP doesn't care, although if you're just sharing a single wire, it's hard to imagine how things could get out of order. So there's no need to support multiple things. So all of this stuff you don't have to deal with. If necessary, another layer will take care of it. Okay, so very quickly, what does the PPP frame looks like? You start with a flag. Again, we're at the lowest layer. We're talking straight from the wire. So we need to know when a frame has started. So there's a special sequence, 0, 1, 1, 1, all 0, all ones and 0, which indicates that a new frame has started. Okay. There is an address field, but as we said, it does nothing because it's being used to connect 2 points. You don't need an address to connect 2 points. Another field is control. Again, it's something left there for possible future expansion. It's not used right now. Here is a protocol That is, are you going, on the other end, is it IP or something else that you have to hand over your data to? So that's the first meaningful field we've had. This is info. I guess we can move along. It's the same header. Info is the actual data, and then there's a checksum. Okay, so I guess it's a 2 or 4 byte checksum, and this is a variable length. So this would be, bulk of the frame, and there's a little bit wrapping around it. So very, very simple. Yeah, so the checksum is the same CRC checksum that was used in Ethernet, and we looked at in some detail a class or two ago. Okay. Any questions here? Okay, so there's one interesting thing in this protocol, which we can see here. So you start with a flag that looks like 01110. Let's call this sequence X, and you end with the same sequence X, right? So what you're saying is I'll start with an X, and in between I can say whatever I want to say, and when you see an X again, then I'm done, and that frame is finished. Now the question here is, what if you wanted to send X? Okay. So that is what was the significance of a line earlier, that you should be able to send any bit pattern. Okay. So you're sending X, you really wanted to send X followed by Y, Z, but if you just look at this, you're going to separate this and say, this is my frame, because you've seen another X, and then you're going to throw the rest of them away. Okay. So how can we fix this? Without dramatically changing everything? Any ideas? So you want some way to be able to say that this is really X, Y, Z versus this being the whole frame. Okay, sure, if I give you enough time, you'll figure it out. You use something called byte stuffing, which is that once you once you put, every time you have an X in the actual data, okay, not the flag, you replace it with 2 X's. Okay, you replace it with 2 X's. So that's all you have to do. So if the actual data was here, so as you reach here, okay, you've seen A, B, C, D, and then you've seen an X. And then if you are on the receiver side, so if there's another X right following it, then I know that the user was actually trying to send X, because my convention is that you replace X by 2 X's. So I'll never see a single X in data. Okay, but so if this is what you see, then you know that. So the data, then you translate it, and you have A, B, C, D, A, L, F, H, Y, and then you put just 1 X. You know the other one was sent there just to not to confuse you. Okay. Now the only other thing left is, now you see X again. Okay. So if it is a real endpoint, this has to be followed by anything other than X. Okay. So if you have this flag, you put anything but 0111110. Okay, that makes sense. Okay. So that's all there is here. This is saying exactly the same thing. The idea is that again, you have that sequence. It goes through PPP. It stuffs it That's byte stuffing. It puts a copy right after it. Other side of PPP knows exactly what's going on, removes one of those, and keeps the other. Okay, and you can still use the single one for boundary and double one to actually carry data. Okay, any questions on this? Pretty straight. So this is some more boring stuff. So the other things PPP has to do before it can exchange data, it has to configure the frame length, authenticate, and so on, and find out